Hello, in this video we're going to talk about hematopoiesis. Hematopoiesis, as the name suggests, hemato refers to the blood, and poiesis is essentially, formation of. And hematopoiesis, it refers to the commitment and differentiation process of a stem cell to the different types of cells we found in the blood. For example, our red blood cells. Now, hematopoiesis, which is the making of these different cells, they occur mainly in the bone marrow. And this is particularly in adults. This is referred to as medullary hematopoiesis. But hematopoiesis can also occur in other tissues such as the liver, thymus, and spleen. And this is called extramedullary hematopoiesis. And we'll learn about that in this video. So let's begin by zooming into the bone marrow. And in the bone marrow, we can find hematopoietic stem cells. Hematopoietic stem cells can, first of all, differentiate into either what's called a common lymphoid progenitor cell or a common myeloid progenitor cell. The common lymphoid progenitor cell then further differentiates into different lymphoblasts with different genetic profiles. And this will allow them to form and mature into different types of lymphocytes. So here I'm just drawing the bloodstream because as cells exit the bone marrow, they will enter the blood. So these different lymphoblasts, with the different genetic profiles, will become either naive B cells, pre-T cells, or natural killer cells. Now, also common lymphoid progenitor cells can differentiate into certain types of dendritic cells. The dendritic cells, when it's formed, will move into tissues and becomes what's known as a lymphoid dendritic cells. Dendritic cells are peripheral antigen-presenting cells that are actually very important in the connection between the innate immune system and the adaptive immune system. So that was the lymphoid progenitor cell lineage. Now let's look at the common myeloid progenitor cell lineage. And it's important to know that the outcome of these lineage are cells that can circulate in the blood. So hence hematopoietic. So again, from the hematopoietic stem cell, it can become a common myeloid progenitor cell. And there are different maps of hematopoiesis that depicts common myeloid progenitor cell differentiation. But how I'm going to show you is what I think is the easiest. Anyway, the common myeloid progenitor cell can become myeloblasts and eventually become granulocytes. These granulocytes are cells containing granules, and they can either be band neutrophils, band basophils, and band eosinophils. So neutrophils, basophils, eosinophils. And these granulocytes are band cells because they are immature. But once they enter the circulation, they mature and become what we know as neutrophils, basophils, and eosinophils respectively. Neutrophils are important in the acute response to infection and inflammation. Basophils are important in allergy and parasitic infections, and eosinophils are also important in allergies and sensitivity. The common myeloid progenitor cells can differentiate and become pro-monocytes and mast cell precursors. The pro-monocytes then mature and become what we know as monocytes. Monocytes are essentially circulating macrophages, and so once they move into a tissue, such as the skin, they become tissue macrophages. And macrophages are antigen-presenting cells, which again are important in the connection between the innate immune system and the adaptive immune system. The monocytes or pro-monocytes can also become dendritic cells. And if they become dendritic cells in the tissue, they are referred to as the myeloid dendritic cells. So again, we have two important antigen-presenting cells, the macrophage and the dendritic cell. The mast cell precursor can become mature mast cells once they enter circulation and move into tissues. Mast cells are very important cells in allergy, the inflammatory response, and hypersensitivity. Finally, the common myeloid progenitor cell can differentiate and become megakaryocytes with stimulation of thrombopoietin, a hormone produced by the liver and the kidneys. Or the myeloid progenitor cell can become erythroblasts through stimulation of erythropoietin, a hormone released by the kidneys. Let's look at megakaryocytes first. Megakaryocytes are normally present in the bone marrow, not in the circulating blood. But these guys give rise to the platelets we find in the blood. Megakaryocytes rupture, releasing platelets into circulation. And platelets are very important in clotting. Erythroblasts are still nucleated red blood cells, meaning that they have a nucleus. But once these erythroblasts enter circulation and mature, they become erythrocytes, which are anucleated. Erythrocytes are our red blood cells. In adults, healthy adults, hematopoiesis occurs in the bone marrow, particularly in the pelvis, the vertebrae, and sternum. However, hematopoiesis can occur in other organs, and this is called extramedullary hematopoiesis. And let us look at a graph with X being the timeline. Here is birth and down the X-axis to 70 years old. And on the Y-axis is hematopoiesis, where the blood cells, the different blood cells are made. So before birth, so when you are a fetus in the uterus, hematopoiesis occurs predominantly in the liver and the spleen. And this is the fetus we're talking about. So in the fetus, hematopoiesis occurs in the liver and spleen. But then it drops off by birth. And this is because slowly the bone marrow will take over the role. And by adulthood, the bone marrow has the main role in hematopoiesis, particularly the vertebrae bone marrow and the pelvis and sternum. Hematopoiesis occurring in the bone marrow is termed medullary hematopoiesis. It's interesting to note that hematopoiesis also occurs in the lymph node during adulthood, but at a much lower concentration and usually occur more often during periods of infections. So what is very interesting is that the liver and spleen, as one might suspect, has no to minimal role in hematopoiesis after birth. However, they actually do have a role, particularly during periods of infections or during pathological changes, such as in certain diseases. When other organs perform hematopoiesis aside the bone marrow, such as if it happens in the lymph node, spleen, or liver, this is called extramedullary hematopoiesis. When you think about it, a child with an infection, their liver or spleen can sometimes enlarge. And this is because the spleen or the liver is working harder to make more blood cells. But this is usually self-limiting and goes away.